Our second speaker is Peter Czibik from RisingStack, and he's going to talk about consumer-driven contract testing and Node.js. Yeah, okay.
Very serious topic, quite long. It has a subtitle, which is verification across service boundaries, which is, again, long. And I have a subtitle, and that is how to reliably ship code when multiple teams are working on multiple parts of a single product, even longer. You're going to know what this means in a few minutes. First, a few things about me. All those technologies that I really like. I consider myself a nerd in general. I'm a senior Node.js developer, Linux enthusiast, lover of programming. Why am I reading this? It's me. And I'm generally a nice guy. So if you'd like to grab a beer, talk about something that's on the slides or something else, maybe grab a beer. Today, we are going to Anker, right? So we have a reservation. Let's get into it. So first, I'm working at RisingStack. I'm a senior Node.js developer, consultant, and we help companies succeed with microservices. Who here works with microservices? Raise your hands. Yay, there are a couple of hands. Microservices, basically, when you try to ship a single application in multiple parts, because probably multiple people are involved. And a general approach to microservices looks kind of like this. It's not simple. We have, for example, look at that guy with the blender over there. His responsibility is only pushing one button, right? I mean, how hard can it be? You just push a button, Blender opens, some things fall into it, and then it just integrates with other parts. But this is the part where what we are currently I'm going to talk about is how you can make sure that your interfaces, which in this case, this guy has two interfaces, or actually three. One that it falls into it, and the other two are the moving parts on the other side. So consider that as our example right now. I have a story to tell, and it is a story not mine, but someone working at Atlassian. Probably you know them from Jira. They're a super amazing project management service, right? I mean, everyone loves it. Two independent services. They had payment and users. And they noticed that something is wrong in payment. And you get an alert, you wake up in the middle of the night, and then you see that something is not quite right. There was somebody in the users working, well, both of the services were independently deployed. They were microservices in the whole architecture, in Atlassian, payment in the users. People who were working on the user service, they changed a single letter in the JSON response. I mean, they wanted to do good. I mean, those people, they just wanted to make it look right. It's an array. It should be users, right? But the problem is that it breaks some other stuff in the whole architecture. And there's actually no worse thing than not letting your users pay. You want their money, right? I mean, why not? How can we avoid problems like that? We have to write tests, many. And many different kind of tests. If we go back to our microservices example, everyone loves this GIF, so as much time we can look at it, is the better. But I mean, we have to write tests because there are so many layers of this. This small Blender guy, let's go back. We have to test that the button is working right, the lid opens, and the small blue things fall into the right place, right? But what kind of test, you may ask? This is a test pyramid. If you're not yet familiar, it describes how. So there are different kinds of tests, you see. There are unit tests, integration tests, and end-to-end tests. The test pyramid describes how many of them we should write based on these things over here. Unit tests are super cheap to write, and they are fast to run. So if you have a unit test, those are, in the JavaScript world, generally are like mock-up type tests that you have. And then you make some expectations, and then your code runs, and it's fine. integration tests are you're making sure that the whole system works as intended and your endpoints are working and stuff like that. End-to-end tests are like the UI tests that we have in place, that there's a robot kind of AI super intelligent thing that presses some buttons and then things happen, and then you observe the side effects. This is a pyramid that we have here. UI tests are slow to run and really expensive to run because you have to have a browser kind of thing, and you have to have instances of those services available for the UI to call. But these things are not enough. That's what I'm saying. We need to go deeper. We have to test actually beyond borders, not just in the level. When we're talking about microservice architectures, we are talking about things, well, not only microservice. This applies to client-server architectures as well, because when we are working on clients, for example, these are deployed separately to our servers, because these are like super React applications that are written in ES 2000 something, and then we have separate code bases we want to deploy. The UI team wants to deploy separately because they want to change the CSS. The backend team want to deploy separately because they want to change an S in the response somewhere. They both have individual deployments, and then they are written in multiple languages. So it's quite hard to start the testing beyond borders. And as I've talked already about, this applies to server-to-server communication, for example, in a microservice architecture, or server-client communication too. And these concepts that I'm going to talk about will apply to both worlds. I have solution A for testing beyond borders, mocking. A programmer typically creates a mock object to test the behavior of some other object in much the same way that the car designer uses a crash test dummy to simulate the behavior of a human. So when we talk about mock objects, they are usually some kind of fake objects that we create just for a single test case. So when we are talking about testing beyond borders, so like inter-service communication, one service calling HTTP endpoint 1, and then with mocking, what we can do, we can maybe use a library that we usually use called Nock, N-O-C-K. It creates HTTP mock objects, and it is really light on resources. It creates no data pollution, meaning that it's not going to call a production service and create like user entities or something like that in the database. And it spares maintenance cost because you don't have to maintain actually anything. It points out issues quickly. You can see that this test failed at this part, and then it's idempotent, means that if you call it multiple times, it's going to return the same data, or at least it should. It's not trustworthy. By trustworthy, I mean when we're talking about integration points, usually the team that is creating tests for service A will create the mocks for service B to test service A. Hope it makes sense. But when somebody creating tests, they are going to go to the documentation of the service B and then read that, and based on that create some mock data, mock objects that they are going to use. And that's not trustworthy because it's not actually calling something in there. It's not actually running actual code written by a human or some supercomputer, but it's going to call itself. And there's another solution what we can use is we can use an instance of an upstream service. When we're talking about containers and stuff like that, we can think of an instance of an upstream service as like a Docker container provided by the other team. I'm working on service A, and I want to test service B. I ask some DevOps engineer from service B, and please give me your Docker container so I can use it in a test. And then before your tests are getting run, you Docker start something. But you know that's kind of hard to use other team's code without actually knowing and without actual like super long documentation. And it's trustworthy. It's the same thing I've talked about before, is that if actual code is getting run and you're calling an actual Docker container running the code that is going to be run in production, you can trust it. It's going to return the same data if it's the same container. But it's expensive. You know, it has costs that you might not even consider. You have to learn how these things work. You have to learn how to spin up their service. It might require Postgres connection, RabbitMQ, Redis, this and that, and they might not have prepared their service for just running it in test mode. It's non-idempotent, meaning that multiple calls to the same service can return some kind of maybe stale data or data that's not like up to date. So it's really up to the people who are implementing the service to make it idempotent, but it's not. Sometimes it's just not the case. These are usually those tests that you have to run 5 or 6 times to make it pass. You know, we've never done that, right? To wrap it up, we have mocking and we have an extra instance. One of them is idempotent, the other is not. One of them is light on resources, the other one is resource heavy. Cheap, but we have to consider its trustworthiness to balance between the two. And these are totally legit test cases, test methodologies for testing beyond borders. So if you're using these things in product to test your production systems, it's totally fine. But I have a solution C, and then C is for contract. And contract testing is what I'd like to tell you about. Is that it has? I have a slide over here. Let's see. This contract testing fits somewhere in between or covers both parts of the test pyramid of integration tests and end-to-end tests. So if you'd like to position this part somewhere in the pyramid, it's right there. If we go back, we have contract testing. And by contract, we are defining an interface between, as I talked about, service A and service B. And what a contract is just an interface. It describes an interface that I'm going to return this JSON for this request. And then both parties will use this contract, this interface, to test. And contract testing will use real data, has no extra infrastructure cost, because we're going to see how it fits into our current testing pipeline, and it does not require you to spin up a new service, to write, well, you will have to write some extra code, but it has no extra infrastructure cost, and is fast with occasional synchronization in between the server and the client, and it is really easy to scale, because we're going to see how, but you can pull down these contracts from a central repository, and then anyone can test against it. And it is quick setup time, so it doesn't require a bunch of extra code, and it is very stable. You can expect the same results as we've talked about with idempotency and reliability. And again, it fits somewhere in the UI and the service layer. And then there is, to contract testing itself probably has multiple implementations, but none of them is really well spread. So consumer-driven contract testing is the thing that we are going to talk about. I'm going to show you. And it has implementation steps as the client. So we're talking about server and client, or server communication. We have service A, and then we have service B. I'm going to call service A our client, because that is the one that's going to consume some resources of service B. The client, service A, makes expectations. For this query, I want some data. I want this set of data to be returned. And then the client itself, within its test pipeline, uses these expectations to test. And then we serialize these expectations to language-independent format. We take these expectations, transfer it to a central repository, and then the server can pull these expectations down, and then the server then will use these expectations to test itself. This is the flow of a consumer-driven contract testing pipeline. And there's a library that implements most of, so you can implement this yourself. You can create a set of expectations, and then these can be also in JavaScript. I mean, all homebrew solutions are fine. I'm not currently advocating for this library. What I'm advocating for is when you're working in a scenario that there's a client and the server communication or server to server communication, you want to test beyond borders. You want to test integration parts from one to another. How you're doing it doesn't really matter. But there's a library that already handles a bunch of things for us. It's called Pact. They have a nice website and a logo, so it's probably a good project, right? That's how it works. So Pact is an implementation of a consumer-driven contract testing, and it uses JSON as that serialization layer. So it's really language independent. You can consume JSON in any kind of language. And currently, there are libraries already out there for multiple languages like .NET and JVM and JavaScript. I know there's Rust in the making, so a bunch of others. So I have a small demo. I don't want to run the demo. I have instructions for you guys if you want to ever run the demo yourself. But I know I've done so many demos already, and all of them just failed. So I'm just going to show you some code. Oh, we're not winning yet. I'm just going to show you some code that I have here. What you need to actually implement all of these things. And it's going to be in Node.js. Wow, amazing. So what we have here is we have a client. And you're probably already familiar with the request module. It's a wrapper for HTTP requests. And what we're doing here is we're making an HTTP request to give an URL to retrieve some products. It is? Great. I pre-checked it, man. I mean, I went there. It's even visible from our office. Ferenciek tere. Yeah, I mean, so we're making a request with a query, and then we're saying this is a JSON request. It doesn't really matter. What really matters is we create expectations here. And with these expectations that we have, that for products with a given query, it will respond with, and there are some helper methods on this Pact matchers, like this object should look something like, we're all used to this. We don't want to exactly define IDs or something like that. So we have all these helper methods for us to use. So for this request that is like the product that has this query, it will respond with 200, and each of the products should look something like this static JSON that we have over here. And then we have these expectations, and we transfer it to a repository. That's what Pact gives you. It gives you a Docker container that you can run and then configure your stuff to send it over to that Docker container. And it's going to save it in its database, and everything's going to be fine. And you just put all those things to your server, and then you use that in the server part to test everything. And this is the server, consumer test. And there is actually some extra setup that you can do. For example, you're creating fake products. It has one product. This was something that we have described here in the interactions part. it has one product. This is a state. So we're even describing what state our server or provider, because this has these terms. Pact and most of other libraries has this term. It's provider, which is a server, and consumer, which is a client. And then we can describe state, and then this service should, there's a test setup, and the state should be one product, so we create a product. And then what we do is we verify the pacts, and we get on with our lives. And we can run these tests. So we have all these tests to run in our CI pipeline, and every time, so a client will make new expectations, right? And next time, our service that will be deployed, if we go back to our example of Atlassian, if someone changes an S in the JSON response in the server part or the provider, they run the tests against their Pact JSON thing, then they are going to be instantly notified that, hey, you should just reconsider this deployment. Let's just revert. Then you compare this with other tools like blue-green deployments, and maybe let some, if these expectation pass, then you might integrate it to your existing testing and verification pipeline. So there are a bunch of things you can do with it. And I'm not saying that Pact is the only way to do this. I'm saying that if you are working in a scenario which involves multiple parties, multiple teams working together, you should make sure that you never, ever break your client's code. And then it's going to be a win-win situation for everyone. Thank you for your attention. And if you have any questions, please ask them right now, or maybe Ferry is around, so he can pass you the, yeah, there you're here.
Yeah, right now. So here's the mic. And anyone has questions, maybe? Great.
Yeah, so am I right to assume that basically what you're advocating for is like something similar to BDD, like behavioral testing, where you have a scenario that the users describe, and then basically a DSL, and then you implement the DSL.
Yes.
In the service. Right?
But not just within the boundaries of a single server context, but also it's like in between multiple services. So yeah, it's basically an implementation of that. And a good one.
Anyone else, maybe?
So my question is, have you ever done this kind of testing across companies, in which one company is asking and using services?
I have not personally deployed it to any scenario like that, but I don't see how it could not work. So the only thing that Pact might not give you is some authentication layer. Does it give you authentication, by the way? No, it doesn't. So then you would probably have to set up some kind of internal network between the two companies, and that might be something that might cause some security issues. But we have successfully used it in between teams, and I've seen it work in between some teams that were working individually. So I don't see any problem making this work in between multiple companies.
So just one more question.
Yeah, go ahead.
Follow-up. If, as I understand, all you have to do is upload to a repository your contracts from one server and just share that repository, which only has contracts, and that's it. So if both companies access that repository, then
yes.
Okay. Thank you.
Yes, they have a Docker container. I even have some.
Sorry, just to add to that.
Okay, so if you use the Pact container, it actually gives you a nice little UI as well. So you're going to be able to browse the uploaded pacts and see if they are verified by the clients, and which client verified it, which didn't, which failed, and so forth. But actually what you said is right. It's only that you lose the UI in that case.
Yeah, and we have this repository is public, by the way. It's RisingStack. It's on GitHub. RisingStack Pact example. Let me show you really quickly. And yay! So this is the one. It's public. You can check it out. It has all the code. I don't claim fame for this one. This was all written by the fine gentleman sitting over there. I mean, it's good. In the package JSON, there are some jobs that like Docker run, and then we have this broker example over there that like handles. So it's just a Docker container you have to run, give it the URL, and it will shove the JSON in there so other teams can pull it down. They made it pretty easy to work with this one, and you should start at least give it a go. And if you like, they are looking for contributors. They have their issues marked as good, first contribution, so they're generally nice people too. Yeah.
I got another question that do the server developers also write their pacts, or just the clients who
it's
want to use it?
just the client, and the server uses that to verify. If the server is also a client, you know, it can happen. It might call back or might call some others. Then they will have to write their own pact stuff.
So if I have a server and it has, I don't know, 10 clients, they all write their pacts?
No, each of the clients. So if you have 10 clients, that means that you will have to be verified against 10 clients as a server. If you are a client that connects to 10 servers, then you will have to write 10 of these pact tests.
So the clients independently write their own pacts, basically?
Yes.
So if there's a new client, it has to implement their own tests to... see. Thanks.
Hence the name consumer driven. So consumer is really the client here. And then
If I may add again, so actually
Wait a minute, because
without this kind of stuff, you would mock the server anyway, right? So if you're writing your unit tests, you're mocking the server all the time and all the 10 consumers, right? You're doing the exact same thing here. It's only the mocks themselves that create the pact. So a mock itself is already a contract, right, that has to be fulfilled. And you just share this contract with the server, and in the mock you say that calling this, I'm going to get this answer, right? So practically, Pact is going to call the producer, the server, based on that mock, and we'll check if it got the answer that the consumer expected, right? So it's not really an overhead in that sense, because you already have these mocks anyway.
Do I see the other clients, consumers,
Well, they're on the Pact broker server, so they're in a unified kind of repository that I mentioned.
I'm not sure about if you like share. So if you share the same test in between clients, right? That's what you're asking. I'm not sure if you can do that. Can you? I mean, that's
on the Pact broker.
yeah, anyone. But that's, or at least I've only seen the implementation part on server pulling that down, but not client pulling that down.
Oh yeah. The client should not.
Yeah, the client should not. So you have to like implement it multiple times. Or at least, as far as I know, you have to do that. There might be something hidden in the documentation, Or if you're up to that, we can create an issue. We can also implement it in another session, but not today, probably.
Okay. Anyone else? Maybe? One last question? No? Okay. Let's continue it in OnCare, I think. So thanks, Peter, for your amazing talk. I think we really liked it. And
thanks for having me.
Yeah. Thanks, everyone, for showing up. For the next time, we will order more beer and more pizza, I promise. So there will be